Hi guys, welcome back. Let's start a new chapter, quantum numbers. Okay. It's a very easy chapter. NEET la idu romba mukkiyamaana chapter edunalana oru question varum idilende idu based ah oru question varum. It's always easy and also it never takes time for solving. So out of 45 questions in chemistry, there are questions like quantum numbers and few other chapters where everyone has to attend. This is a chapter so vital because you save time and also you don't have to revise during revision time. You will always remember if you write your notes very well and study very well and write key notes just during revision time. Konja na irukum adha nyabagam vechika vendiyadhu math ellame practice la vandrum, and it's a very small chapter. By the way, this comes under a bigger chapter called atomic structure. I start with quantum numbers now. I'll do atomic structure unit later for one particular purpose. I'll wait till physics sir finishes atomic structure. In physics, atomic structure comes in detail, whereas in chemistry it doesn't come in detail, and also 90% of what comes in chemistry, the wavelength, the series, Balmer, Paschen, bracket, fun series and all those comes in atomic structure of physics as well. So once you get there and also do the Rydberg equation and all in physics, then my job is to just look at the chemistry side and revising the remaining atomic structure. Okay, let's focus on the chemistry side of atomic structure chapter, that is quantum numbers. Quantum numbers are extremely vital when it comes to looking at a periodic table. So when you look at a periodic table, you know that the periodic table has a shape something like this. Correct? This is what you have. You have S, P, D and F. Each of these have a different quantum number, and within them there is 4 set of quantum numbers, right? We are going to see them. Each of them within each other, they are differentiated based on quantum numbers only. So we will see the detailed periodic table in the first lecture of periodicity, but at least at this point we want to just introduce the periodic table and see why we study quantum numbers. Each electron goes anywhere here is decided by a unique ID, like our other ID. 4 set of quantum numbers. We are going to see them now. Many of you might have already seen quantum numbers in your school. Regardless, I will try to teach from the basics just in case we don't omit any particular concept in there. Okay, when it comes to quantum numbers, there are 4 different quantum numbers and they have their unique symbol. The first and foremost is denoted by a smaller case n. This is called a principal quantum number. Second is R, smaller case l, azimuthal quantum number. Third is smaller case m. It's better to put a subscript L. This is magnetic quantum number. And the last one is m sub s, spin quantum number, sometimes also called magnetic spin quantum number. Now what do they represent? When it comes to n, it basically tells you the shell. So if you were to draw a nucleus and then you have different shells, this is what we have. Okay, so this is first shell, second shell, third shell, fourth shell, and shells are where the electrons are present, and in the nucleus you have your protons, neutrons and various subatomic particles, including one that is named after an Indian scientist, Bose. It's called boson. Alright. Okay, now when you look at the shell, these shells, the numbering 1, 2, 3, 4, basically this is like an onion. So onnonume or orbit nu solvanga. You can call them as shells or orbit. Okay. Now orbit is a better word than a shell because shell is completely surrounded, whereas an orbit you just see it in 2 dimensions. It's much rather easier, but regardless it doesn't matter. This orbits, first orbit, second orbit, that's called a principal quantum number. And orbit n equals 1 is called KLMN. This is old concept, KLMN. Now they don't use it anymore, but it is in your syllabus, so know that KLMN belongs to the corresponding shell. And that's a capital case L, this is a smaller case L, capital case M, smaller case m, so that you don't confuse. Alright, now that I have these orbits, that tells you the principal quantum number. So when you take a periodic table, let's draw a periodic table. It's easier to identify and remember. So S, P, D, F, all those. Okay. The principal quantum number tells you a couple of things. First thing it tells us about the energy of the orbit. So n equals 1 oda energy வந்து n equals 2 oda கம்மியா இருக்கும். n equals 2 வந்து 3 oda கம்மியா இருக்கும். So as the n value increases, energy increases. Because each orbit has inside orbitals, it also tells you energy of orbitals as well. The other thing that it tells you is, remember this is a nucleus. So nucleus la irundhu 1 வந்து பக்கத்துல இருக்கு, 2 தூரமா இருக்கு, 3 இன்னும் தள்ளி இருக்கு. So it also tells you the distance from nucleus, or you can also say size of orbital. Now imagine இதுதான் 1s, s மட்டும் இப்போ பார்க்கலாம். இது 1s ஓட சைஸ், இது 2s ஓட சைஸ், 3s ஓட சைஸ். ஸோ சைஸும் அதிகமாகுது, ஆல்சோ கோர்லேருந்து டிஸ்டன்ஸும் அதிகமாகுது. ஸோ யூ கேன் டெல் ஆல் ஆஃப் திஸ். Azimuthal quantum number, what does it tell you is, it tells you two things. Primarily it tells you shape of the orbital. Orbit oda shape solladu. Orbit is pretty much spherical. Orbital oda shape sollum. Okay. Also it tells you energy among subshells. Now இது என்ன எனர்ஜி சொல்லுது, இது எனர்ஜி சொல்லுதுன்னா, இது 1 2 3 இன்க்ரீஸ் ஆனால் உங்களுக்கு எனர்ஜி அதிகமாகிட்டே போகும். 1s is smaller or lower in energy than 2s. 2s is lower in energy than 3s. It is telling you that. Okay, so ஒரே ஒரு ஆர்பிட்டல் எடுத்தீங்கன்னா அந்த ஆர்பிட்டலோட எனர்ஜி அடுத்த ஆர்பிட்டலோட அதிகமாக இருக்குமா இல்லையா நீங்கள் பார்க்கலாம். வாட் இஸ் திஸ் டெல் யூ இஸ், இங்கே நம்ம ஆர்பிட்டே கம்பேர் பண்ணோம். இங்கே என்ன கம்பேர் பண்ணலாம் அப்படின்னா சப்ஷெல். ஓகே, ஐ கேன் கன்சிடர் whether S or P or D. Obviously S is lower in energy than P, P is lower than energy than D. So அது பேர் subshell. இது shell, இது subshell. இதோட energy சொல்லும். So together they tell you the energy. We are going to see that soon. Magnetic quantum number, as the name says, tells you the magnetic properties of orbital. Okay, it tells you about the orbital. Spin quantum number tells you magnetic spin property of particular electron. And the orbital, ஒரு orbital அப்படின்னா அதில் 2 electron இருக்கலாம். So it tells you about the spin property of an electron. So again, orbit, orbital, orbital, electron itself. Now how do you want to see this? Let's look at it this way. Okay, now let's say this is the city that you live in. Okay, city இல்லைனா நீங்கள் இருக்கிற ஏரியா எடுத்துக்கலாம். wherever you are right now, that is the area that you live in. For example, our academy is in Ayappanangal in Chennai, so I can take it as Chennai or I can take it as Ayappanangal. Okay, for those of you who don't know Ayappanangal, let's make it a simpler word, Porur. Okay, this is where we are. So in Porur, where is my house situated, or in your locality where is your house situated? Okay, so now let's say for example the city, that is your principal quantum number. It tells you which city you are in. Okay, and then next on the city la which street you are in. Okay, or let's even make even simpler. Okay, I know my city, I need to know which street I am in. Okay, in the தெருவில் இருக்கீங்க, that is your n, principal quantum number. Okay. So I know that there is a street here that goes, multiple streets are there, there is a dissectional street and your house is here. Okay, sorry I didn't give you a corner plot. Alright, now that is where our house is. Now what I know, in the street la in house la, in the street la irukku, in the street la, so I know my street, that's my principal quantum number. Next, on the street, which house are you in? That's your azimuthal quantum number. I am in this house. Okay, in this house there are multiple rooms. Which room are you in? Which is your room? That's your azimuthal quantum, magnetic quantum number. In the room and it is supposed to be assumed that each room can hold 2 people. So let's say, for example, you and your brother or sister is there. So that's your last one. Male or female, doesn't matter, that tells you MS. Okay, so this is pretty much what it tells you is exactly we are pinpointing your location. Okay, so what this NL, ML and MS gives you is basically a unique ID like Aadhaar ID. Exact and the nalu match agadhu neenga orthara dhaan irpeenga. That is what this is giving you. Now when you look at the periodic table, let's look at whether this follows. These are our streets. So these are our streets. N equals 1, 2, 3, 4, 5, 6 podala namakku. Okay, house. And the street la, am I in this house or this house or this house or this house? Okay, so let's say for example we take this one. This is our house, L value. Room. In that I have 3 rooms. D orbital na 5 rooms. S orbital na ஒரே ஒரு room இருக்கும். F orbital na 7 room இருக்கும். Just similar to drawing boxes. S, P, D and F. These are the maximum number of orbitals possible for each of them. One, two, three, 4, 5, 6, 7. So these are our rooms. In that room, in each of the room there can be 2 people, so on and so forth. In some rooms there are nobody. Okay, some rooms, for example, we can have this. Some rooms there are nobody, in some rooms there are only 1 person. That's what we are going to see right now. But at least you are getting an idea what this means. So it tells you about principal, azimuthal, magnetic and spin and what do they really mean. Alright. Okay, now that we saw what these actually mean, what is the type of data you can get from N, L, ML and MS. Now let's look into what are the possible values. For a principal quantum number, the values are N equals 1 all the way to infinity. So this has to be an integer, it has to be a positive integer. N equals 0 doesn't exist. First street வந்து first street தான் நம்ம சொல்லுவோம், 0th street நம்ம சொல்ல மாட்டோம். So first street, second street, third street அப்படிதானே இருக்கும். So how many streets can you lay out in your city? As big as the city gets. Similarly, as big as the orbitals can happen. So infinite orbitals இருக்கு. Now are there elements that occupy so much? No, not really. So we pretty much stop at 6f, 5f, அவ்வளோதான் calculation கொடுப்பாங்க உங்களுக்கு. Okay, azimuthal quantum number. So what this is, you basically have for given n value. So I have to tell you the n value. So I have to tell you which street. So on the street la evlo veedu irukkalam. How many L values are possible? So L values are starting from 0 to n minus 1 L values. 0 la irundhu aarambichu n minus 1 varaikum varum. Now what are the possible values? For example, n equals 3. So what are the possible values for L? L equals 0, 1. Let's put it this way. L equals 0, L equals 1, L equals 2, L equals 3. Alright, now ML value. The ML values are starting from, for whatever L value you take, idhil nariya L value varum, 0, 1, 2, 3 varum. Okay, so it will start from minus L, minus L plus 1, actually no, sorry, minus L plus 1, goes through 0, keeps going all the way to L. Normally minus L to plus L nu solvanga. I am just putting an extra point. For example, I am going to write my ML values. Minus L is 0, 0, 0. So this is 0. So when I have my L equals 1, I have minus 1, minus L plus 1. Minus 1 plus 1 is 0. Already I hit my 0. So I have minus 1, 0, plus 1. Now let's look at 2. So I have minus 2, minus 1, 0, plus 1, plus 2. And the last one, -3, -2, -1, 0, +1, +2, +3. And the MS is easy. For every ml, you have plus half, minus half. Plus half, minus half is something that is given by humans. Okay, so this is clockwise spin of an electron. This is anti-clockwise spin of an electron. It's not actually charges. Electron is -1. Now clockwise is plus half. Humans now. So nature doesn't know clockwise or anti-clockwise. It's exactly same. Only we decided that because most of them are right-handed in the world, we call this the right way of doing, right hand. But then there are left-handed people. So only we gave that. Similarly, we gave this. Just know that these are exactly opposite in spin, but the magnitude of spin and also the energy and everything is the same. Okay, so each of them will have, for example, I'll write it for this alone. This will have minus half, plus half. Similarly for all of them. Okay, so now another thing we want to know in our azimuthal quantum number. We can have the value of L equals 0, 1, 2, 3, 4, 5, 6. How many values can you have? You can have n minus 1 value. So what is the maximum you can have? Theoretically, this is infinity, na? Infinity minus 1. But infinity minus 1 is also called infinity in math. Let's not bring math here. So L value is determined by how many n values are there. And we also give L values for individual orbitals. So this is going to be s orbital, p orbital, d, f, g, h, I and so on. So they can give you a question based on g orbital, although we don't see g orbital normally. Our periodic table actually ends with f orbital. But g orbital for every electron exists. G orbital for every atom exists. Imagine this, you are an atom, you are at the center core, ungala suthi onion mari shell irukku, and let's say for example you are at 4f actinoid. Okay, doesn't mean there doesn't exist a shell outside. There is a shell outside, there is no electron there. Okay, it's just a street that is not developed yet. Now more than that, idukku mela neenga ponale unstable atom universe la, but maybe some other planet has something for because of a certain condition, but at least they can give you this. The moment you know the L value, you should know the corresponding F value, or the orbital ID. Now other thing that we can do is how many magnetic quantum number values will be there for a given L value. So idukku vandu 0, idukku vandu 1 vandu 3 agudhu, 2 vandu 5 agudhu, 3 vandu 7 agudhu. So for a given L is given, total number of ml value is 12 plus 1. Okay, so s orbital ku 12 plus 1, L is 0, 12 plus 1 is, this is 0 plus 1 is 1. Idukku 12, 2 times 1 is 2 plus 1 is 3, 12 plus 1, 2 times 2 is 4 plus 1, 5. Similarly 7, 9, 11, 13, it will go on. And hence we draw this boxes. And so on, 7. So these are basically orbitals, the box diagrams. These are orbitals. It is determined by the L value. L value or energy is determined by n value. Okay, this is how quantum numbers work. I hope you guys are getting an idea about quantum numbers right now. Now, the important thing that you have to know from the quantum numbers is how many orbitals or how many electrons can be present for a given n value or L value. So normally NEET la enna kodupanga, they can give you the n value, or they can give you the L value, or they can give you the ml value. So n value kodutanga appadina, how many L values are there? 0 to L minus, sorry, let's put it this way. There are the L values are 0 to n minus 1. Correct? So now if it is 0 to n minus 1, what is the total number of integers there? 0 include panninga appadina enna irukum? So total number of integers are n integers. So there are, for a given n value, you have n subshells. Example, n equals 1, 2, 3, 4. Let's take 5. So that tells me how many subshells are there, the number of subshells. 1, 2, 3, 4, 5. What are they? L equals 1 அப்படின்னா subshell வந்து S. 2 னா S உம் P உம் இருக்கும். இதுக்கு S, P, D. S, P, D, F. S, P, D, F, G. Now this is something you might have already known. In periodic table there is only n equals 1. 1s மட்டும் தான் இருக்கு. 1p கிடையாது. 2s, 2p. 3s, 3p, 3d. There is no 3f. 4s, 4p, 4d, 4f. 5s, 5p, 5d, 5f, 5g. So now for example, the question can be in NEET is which is the lowest energy level n value for which I orbital can exist. Okay, s orbital, p orbital, g orbital, I orbital. Now what you want to do in NEET is just write this one. I know it is s, p, d, f, g, h, I. 1, 2, 3, 4, 5, 6, 7. So 7i is the first I orbital. 6h is the first h orbital. 5g is the first g orbital. Or other way, what's the first d orbital? 3d. What's the first p orbital? 2p. Okay, this is what this is going to tell you. Now the other one that is going to tell you is if I give you the n value கொடுத்துட்டேன் அப்படின்னா for given n number of orbitals. So n value கொடுத்துட்டு orbitals கேட்பாங்க. Number of orbital is nothing but n squared. Now what does that mean? Let's say for example I am going to give you n value is 3. What are the subshells possible? S இருக்கு, P இருக்கு, D இருக்கு. So example n equals 3, L equals 0, 1, 2. This is S, P, D. Okay. So now how many orbitals or how many boxes there is in S orbital? 1. 12 plus 1. இதுக்கு 3, இதுக்கு 5. So if you add, what do you get? 5, 6, 7, 8, 9. N equals 3, n squared equals 9. What do I have to draw all this? So n squared will tell you the number of orbitals straight away. So the number of electrons for a given n value is 2n squared. ஏன்னா ஒரு ஆர்பிட்டல்லையும் ஒரு பாக்ஸில் 2 எலக்ட்ரான் இருக்கலாம். So number of electrons is 2n squared. Number of electron with same spin என்ன இருக்கும்? n squared. What does it mean is n squared is plus half. There is another n squared number of values with minus half. Together they make it 2n squared. Okay, so this is simple. Now I can give you n value, ask you this, or I can give you L value and ask you the number of orbitals. So given L value, what is the number of orbitals? We know the formula 12 plus 1. Orbitals are boxes thana ml, so 12 plus 1. For a given L value, the number of orbitals is this. Number of electrons would be 2 into 12 plus 1. இது நீட்ல எப்படி ஆப்ஷனில் கேட்பாங்க அப்படின்னா you can just make it as 4l plus 2. இந்த மாதிரி கொடுப்பாங்க ABCD. Number of electrons for a given L value. Now number of electrons with same spin, it will be 12 plus 1 because 12 plus 1 has plus half, 12 plus 1 has minus half. So இதெல்லாமே same spin plus half, இதெல்லாமே same spin minus half. What is the total? 4l plus 2 total plus half and minus half. Okay, this is what they may ask you in NEET. Okay, it's very simple and you want to be very very fast, but I cannot stress it enough. You have to be very very careful reading it. For example, in 2017 or 18 this question came. How many electrons are in an orbital? Okay. How many electrons in a, let's say for example, 3D orbital? Normally the answers would be given as 2, 6, 10, 14, meaning S, P, D, F correlate பண்ற மாதிரி. But most of the students got it wrong because they asked you how many electron in a 3D orbital. So, how many electrons can be there in one room? Your house may have 5 rooms, but how many electron in one room? So, a 3D orbital. So, each of these are orbital. So, idhula edavadhu oru orbital edutha, what is the answer? 2. But many people did 10. How many electrons in 3D orbitals? Abdini ketta, you can say 10. How many electrons in a 3D orbital? 2. How many electrons with the same spin in 3D orbitals? 5. Ena ellame one spin up. How many electron in a 3D orbital will spin up? 1. In a 3D orbital nu sonna ore oru orbital adla evlo spin up irukum one spin down irukum. Okay, this is the pattern of questions you can expect in NEET. Next we will look into a smaller segment, the rules that determine how the electrons are going to occupy a given orbital or a shell or a room, which is your orbital or a subshell, however you want it to be. How you can occupy the given street, given house, given room, all those we are going to see. There are 3 rules that you want to look at. First is Aufbau principle. There is a difference between principal and principal quantum numbers. Principal quantum numbers la varadhu vandu school headmasters mari. Okay, that is the one that tells you major. Okay, so that is what tells you major, that is PIL kadasila principal. This is principal. Principal means the rules that determine. So unga school ku no rule irukum that could be enforced by your principal, but the principals can change, but the rules might not change. This is a principle, this is the rule. Now what it basically does is, if you see here, you may have seen this diagram in your school or textbooks, the order in which the orbitals are filled. Okay, in the order la neenga orbital fill pannum. It will be much easier in life if after 1 2 is filled, after 2 all the 3 is filled, after 3 all the 4 is filled. Okay, but that is not the case. We fill 4s before 3D, so you have to follow this diagram. But do you have the time or the space to draw the diagram? No. So what we want to look at is, one thing we know about Aufbau principle is, it basically tells orbitals with lowest energy are filled before you go to the next higher energy orbital. Okay, but lowest energy fill pannom, adu dhaan lowest energy. Do I have to go through that? Not really. Let's go to our understanding of orbitals. What tells you about energy? So when it comes to energy, my principal quantum number and my azimuthal quantum number tells me about energy. So idu renduthoda combination na energy ah irukanum. So you always fill the orbital, fill from lowest n plus L to higher n plus L. So lower n plus L. So ஒரு ஆர்பிட்டலுக்கு lowest n plus L இருந்ததுன்னா அதை நீங்கள் முதல்ல fill பண்ணணும், அடுத்தது highest போகணும். Now let's compare the diagram with what we have. Let's say for example n plus L value 1s, 2s, 2p, 3s, 3p, 3d, 4s. Okay, 4s, 4p, 4d, F will come 4f, 5s, 5p, 5d, 5f, 5g. Okay, these I am arranging them in the numerical order, but not necessarily as energy order. Now let's look into it. N plus L enna varukum? N plus L, n is 1, L is for s orbital 0. So 1 plus 0 equals 1, 2 plus 0 equals 2, 2 plus 1 equals 3, 3 plus 0 equals 3, 3 plus 1 equals 4, 3 plus 2 equals 5, 4 plus 0 equals 4, 4 plus 1 equals 5, 4 plus 2 equals 6, 4 plus 3 equals 7, 5 plus 0 equals 5, 5 plus 1 equals 6, 5 plus 2 is 7, 5 plus 3 is 8, 5 plus 4 is 9. So are they in increasing order? Not really. 1, 2, 3, okay. Now how do you want to fill it? As you want to fill it, and then there is a second rule. Let's rule number 1, rule number 2. for same n plus L, fill lower n. இந்த ரெண்டு ரூலையும் எல்லா ஆர்பிட்டலுமே ஃபாலோ பண்ணும். By the way, all this so far what I have taught and also these rules are all in the printed sheet I have sent you in the group. So you don't have to write this down. Write down your understanding in that sheet itself, or don't crowd the sheet. Along with the sheet, put a A4 paper and do it. Okay. So now I know that the order in which I am going to fill is very simple right now. 1s, 2s, 2p, 3s, fine. So I am going to do 1s, 2s, 2p. 3s is okay. Then not 3p or 3d, 3p. Then I have 3d or 4s. 4 is smaller than 5. So 4s, 3d. I am at 5. I am at 5. Okay. But this has a lower, idukkum 5 தான் இருக்கு ரெண்டுமே, but lower n value. So I have 3 versus 4. So 4p comes here. Then 4d, sorry, 5 and then 5s. Okay. 5s and then I go to 4d. 4d க்கு அப்புறம் 5p. 5p க்கு அப்புறம் 7 இருக்கு. I go to 4f, 5d, 5f, 5g. Now understand one thing, I am missing here certain things. If you were to write, for example, 5d க்கு அப்புறம் 5g க்கு அப்புறம் 6x, 6p எல்லாம் போட்டால் 6 இங்கே வந்துடும். ஓகே. ஸோ 5p க்கு அப்புறம் we have to write 6s, 4f, 5d and then here 6p varum. Okay, so on. Now this should match the diagram. So if I give you, they are not going to ask you to write everything. They might ask you a set of orbitals and they can ask you to arrange in terms of energy order. Okay, now this should match that. So basically this is called the n plus rule or Aufbau principle. Now here is a couple of questions that has come in previous years. Look at it and try to answer this.